Okay, so in this video, we're going to look at a more practical use of the EKG and basically what happens, why do we use this, and what happens if things go wrong, and what if the normal heartbeat isn't normal. And so I'm just going to walk through a few things that we can see and how we use the EKG in very practical purposes. So if you recall, this is our standard EKG strip right here. Remember P wave, QRS, and T wave. Atrial depolarization, ventricular depolarization, and the ventricular repolarization. And the beauty of this, it allows us to know not just what's going on with the conduction of the heart, but what's going on with contraction, again, because the two are related. So one thing we use the EKG for is to look at abnormalities in this to get a sense of what may be going wrong with the heart. So one big thing we're always concerned about is the actual muscle itself, the heart muscle itself, is it getting enough oxygen? Is it getting enough perfusion so that the muscle has oxygen so it can contract? We can go through metabolism and why that's important, but oxygen, ATP, I think we get that. When that doesn't occur, we call it ischemia, and that's when the tissue is not getting enough oxygen. And what's neat about the EKG is actually that ischemia will cause changes in the EKG. So instead of having to put a sensor in someone's heart, which is really hard, we can actually just look at the EKG. And so one of the things we typically see when tissue becomes ischemic, in other words, some heart tissue becomes ischemic, is that the P wave, QRS, and this T wave, this ST segment, in other words, this area between when the S wave ends and the T wave begins, we call it the ST segment. This segment starts to drop or depress. We call this ST segment depression. And it is the classic sign on an EKG that the heart muscle is not getting enough oxygen. In fact, this is so important. And if you ever had a stress test done or know someone who has, this is one of the key indicators we look for, is when the heart is stressed, whether it's through exercise or something else, is that increased need for oxygen being met? And if it's not, we'll see ischemia, and that's a bad thing. That means there's likely some heart disease there, and potentially some further clinical steps need to be taken. And so let me kind of give you a live version of this. This is our EKG simulator. We actually have this in the lab here. And this is our demo version, so it doesn't have all the capability, but this is a normal sinus rhythm. And so again, I can pause this so we can look. Let me hide our ruler here. We have our P wave, QRS, our T wave. If you take advanced clinical physiology, which a number of you will, we'll go way more into depth in what all these things mean and the grid and all that. Just know that there's basically P wave, QRS, and a T wave. Well, let's look at what ST segment depression would look like. And so if we pull up all our cool things we can do here, let's see. Oh, there it is, ST depression. So, we can't do that. So, forgot the demo, we can't do that. But what we would see is that this area right here would begin to drop. You see that as ST segment depression. Now, that's not the only thing that can go wrong. In fact, there's a lot of things that can go wrong. I mean, quite literally, any step in this process, there can be an issue. Let's start with some common ones that likely all of us deal with. One of these is what's called a PVC, or a premature ventricular contraction. And let's pull that up and show what one of these looks like. Where are we here? Actually, let's do this. Let's just throw in a PVC. So there we go. So, there we go. We'll pause that. Okay. So what you'll notice here, this is our normal sinus rhythm. P wave, QRS, normal, normal, normal. And then we have this ugliness. This is what we call a premature ventricular contraction, or PVC. Easy way to think about this is it's premature, early. And if you kind of think of the rhythm, if this is a song, right? It's like boom, 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 boom. It's like, it's early. Whoa, premature. It's ventricular, which means it's from the ventricles, and it's a contraction. So what's going on is the ventricles are contracting early. That's exactly what this is. More electrically, what's going on is that some cell in the ventricles has decided to fire before the SA node. Well, if that happens, what happens? Well, that means the depolarization starts in the ventricles. But again, remember, if one cell in the heart depolarizes, they're all going to depolarize, intercalated discs. And so we have this backwards depolarization, and it looks like this ugly looking mess here. We call it a PVC. So this is one example. And by the way, we all have these. Every one of you has these. Probably once, twice a day. I have these like once an hour. I'm getting old. They're in and of themselves fairly harmless. There can be issues with these, but for the most part, these happen to all of us. Not uncommon. All right, so that's a PVC. Let's look at PAC. All right, so we have normal. There's another PVC. Okay. Now we got couplets. Let's go back to just normal here. Okay, so here's our normal rhythm coming up. There's our normal rhythm. Right, boom, 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 boom. And now we'll throw in a PAC here. All right, there it is. Okay, so let's look what happened here. We have normal, 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 boom, early. This is what's called a premature atrial contraction. In other words, early atria contracting. Now, this you may notice looks a lot different. It is totally different. It's not wide, it's not ugly, and the reason being goes to the physiology. It's in the atria, right? So these are the atrial cells depolarizing first. Well, that's great, but if the atria depolarize first, they depolarize first anyway, right? And so, in theory, the EKG isn't going to look much different. I mean, okay, this didn't start at the SA node. It started somewhere else in the atria. Okay, but it still started in the atria. So yeah, it's going to look different. It's got a weird looking P wave here because it started somewhere different in the atria. But everything else is the same, right? AV node, the bundle branches, ventricles depolarizing, ventricles repolarizing, all that's the same. So because of that, the QRS looks normal, the T wave looks normal. It's just early. Okay, so that's a PAC. Let's look at some other ones. Let's go back to normal here. Let's see. So what would happen if we had a bunch of PVCs put together? Right, instead of just one, what if we had a lot of them? Well, that would be a fast rhythm, okay? And, oh, you're not going to let me, hold on. I got to move me to the side. Whoop. Let's go to ventricular tachycardia. So what would occur? Well, if you have a number of early PVCs, you're going to have something that looks like this, okay? This is a fast heart rate because, again, everything's early. So in EKG talk, we take it from the Latin, where fast is tachy, cardia is heart. So we say this is tachycardia, fast heart rate. And it's coming from the ventricles, so we call this ventricular tachycardia. And this heart rate is really fast. It's about 100, actually it's almost 280, 260 beats per minute. This is bad. Basically what this is a lot of PVCs scrunched together. And this is when we get really concerned. Individual stroke volume drops, kind of a big deal. So that'd be ventricular tachycardia. There's other ones we can look at here. Let's see, what other good stuff? Atrial fibrillation, I think we can do that. Yeah. So atrial fibrillation, this is really common. You probably see commercials on this, medications to help with your AFib. That's not a lie, AFib, lie, get it? It's called atrial fibrillation. And literally what's going on here is that instead of the atria depolarizing, there's numerous cells in the atria depolarizing. And so instead of a nice contraction, we have a lot of kind of quivering going on. There's not one really specific strong contraction. And so what we're seeing, let me pause here, what we're seeing is a lot of P waves here. And because these aren't very strong, not all of them are strong enough to make it to the AV node to then have a QRS wave. So we get kind of this weird rhythm that's out of rhythm. I mean, you can kind of tell like there's a little space there, but there's more space here. It's really not in rhythm, and a lot of P waves. So this is atrial fibrillation. Let's look at one last one here. I wonder if we'll let's do AV. No, let's do AV block. Sinus arrhythmia, maybe? Okay. So here's another one that actually many of you probably have. This is what I call sinus arrhythmia. So in other words, this is normal heart rate, but you'll notice as it goes through, it's normal, but it's not normal. Like the rhythm, like you couldn't dance to this. You know, it's like boom, 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 boom. It's like, drive you nuts. We call this sinus arrhythmia. We call it that because these aren't PVCs. The P waves look normal. Everything looks normal, except there's just a weird amounts of time in between these QRSs. This is called sinus arrhythmia. A lot of things can cause this. Breathing can cause this. Very common. We see this actually in athletes some. And it's just a slight irregularity in the normalcy of a beat. But again, something we can see in an EKG. There's some other examples in your notes here as far as some other arrhythmias you can look at. Ventricular fibrillation, ventricular tachycardia we talked about, PACs, PVCs. So you can take a look at that. In the next lecture, we're going to review a little bit of Fick equation, and then I'll finish up this chapter.